approach foundry to program this. We can directly purchase one FPGA kit, and a designer is having a liberty to program that. So we are saving the time, and time to market is getting reduced by using a field programmable gateways. Now here you are seeing a simple programmable function. We are seeing potential links, which is between the 2 points. So if we connect these 2 points with a wire, we are able to establish a communication between A to the AND gate. So this is what we can call as programming. So the AND gate inputs are connected to the pull-up resistors here. So you are getting 1 here, always 1, because it is connected to logic 1. So your output is always 1. So if you are this is a simple programmable function. You can program this to work according to your needs. Now next is fusible link technology. This is one type of programming technologies in FPGA, you can say that. So one of the first technique that allowed user to program their own devices was and still is known as fusible link technology. So means user can program their own devices. You are seeing some fuses are there. Programming means you have to blow off these fuses in order to make your chip work according to you. So programming means you have to blow off these fuses. So augmenting the device with unprogrammed fusible links. So you have to unprogram the fusible links. They are already programmed. You have to unprogram those things. Now next is programmed fusible link. See how to program this. What I told you, you have to blow off the fuses. So here they are blowing off and programming. So this is what you are saying, that you are programming your FPGAs. Now the process of removing the fuses is typically referred to as programming the devices, but it may also be referred to as blowing the fuses or burning the devices. As I explained you before itself, devices based on the fusible link technologies are said to be one-time programmable. So the only disadvantage of these FPGA is this, that they are one-time programmable. Once you program these FPGA, you can't further program. So after that, it is simply a waste for you. Now one thing is next technology we'll see is anti-fuse technology. Anti-fuse technology means you are seeing that here one arrow is there and there is no link. So this is unprogrammed anti-fuse. Now unprogrammed anti-fuse, now we want to program these all anti-fuses. So how to do those things? We have to establish a contact between these two. So this is what we can call as programming the anti-fuses. Now how to grow an anti-fuse? So this is what foundry people will follow before they will give an FPGA to us. So you see how there is a metal oxide layer, there is an oxide layer, there is a metal, and there is a substrate. So this is how they will grow an anti-fuse. So this is pertaining to the foundry. We should not concentrate much on this, but this is somewhat informative. We should keep in our mind. Now we'll see mask programmed devices. So what all those? So first we see a background on that. Electronic system in general and computer in particular make use of two major classes of memory devices, ROM and RAM. We all know what is ROM, we all know what is RAM. Read-only memory and random access memory. So ROM is non-volatile. So and RAM is volatile. So if we see the application of ROM means we need ROM where we do not want to change our configuration again and again. It is one-time programmable, you can say that. Like booting of a system. So where that program should be stored? That program should be stored in somewhere in ROM. Similarly, next is random access memory, which is volatile. It is simply a scratch pad. You can use it and after that you can delete this. So this is a volatile. Now we are coming to transistor based mass programmable ROM cell. So this is a transistor based mass program ROM cell. So now we'll see transistor based mass programmed ROM cell. So transistor based means we are using one transistor, and mask program means we are going to use one mask in order to establish this, in order to connect these 2 points. So ROM means read only memory, so it is one time programmable. Once you are programmed it, you can't program this that another time. So this is mass programmable connection. We can see that there is a row and there is a column in order to select this transistor. So where row line is connected to the gate of the transistor and the drain is connected to the column line. So in this way we can connect a number of transistors in a row or in a column, and we can select those based on the select line. So this line is going to select a word, and this is going to select a particular data in that line. Now next technique we'll see is PROM, programmable read only memories. So a transistor and a fusible link based PROM cell. So in this diagram they have shown transistor and fusible link based PROM. So fusible link, it is same like before earlier, but we are going to blow off this connection in order to establish a communication between these 2 points. And this here is logic 1, means this is VDD supply connected to a pull-up resistor, and this is used to select a data or a row. If we are having 1 in this row, this will enable this transistor, so it will act as a resistor, and whatever value is there in VDD we can make it ground. So this is how we can enabling the connections. How it is working, I explained you before. So row line is there, we can connect a number of transistor in an array, and we can select which word and which column based on the select. Now next we'll see EPROM based technology. So here you are seeing a basic transistor where we are having source, drain, gate, and control gate terminal, drain terminal, source terminal. This is a standard MOS transistor. Then how it differs from EPROM is we are having 2 gates in EPROM. One is floating gate and one is normal control gate. This we know that EPROM is we can program it many times. So this floating gate will help us to program this ROM more than once. How we can see those things later. So the only difference between a standard MOS transistor and EPROM transistor is that in EPROM we are having a floating gate which help us to program our ROM twice or more than once. Now you can see a standard EPROM transistor based memory cells. So here you can see there is a floating gate between, this is a normal control gate and here is a floating gate, and this is a transistor. Okay, so this is how it differs from normal transistor. Now there is one more technology, we can say that E-square PROM based technology. What is the E-square PROM? Here in E-square PROM we will use one EPROM and one normal MOS transistor in series. How they are connected in series. This is normal transistor, where this is EPROM transistor, where we are having a floating gate. But the only difference we have to notice between the earlier EPROM and E-square PROM is this symbol. See, this symbol is somewhat down, coming down and then again going up. So this is a difference in the symbol between EPROM and E-square PROM.